Okay, so what are we going to do with some of those phrases like at most, less than, at least? These are some of the types of problems we're going to be able to solve. So in this particular case, we've got 5 boys and 4 girls in a preschool class, and 4 of them get to bring something for show and tell. We want to figure out in how many ways at least 3 of them could be boys. So what I'm going to strongly encourage you to do is, first of all, figure out what that group of kids looks like using the words and or. So at least 3 is a minimum of 3 boys, okay? A minimum of 3 boys. So that means you could end up with 3 boys or 4 boys bringing show and tell. However, if you have 3 boys bringing show and tell and there are 4 kids bringing show and tell altogether, that means you also need 1 girl. So it could look like 3 boys and a girl brought show and tell, or 4 boys brought show and tell. Once you've got that set up, then the calculation is actually quite simple. You just need to follow the pattern that you established. Since the order in which the kids bring show and tell doesn't matter, they all get to share their item with the class. We're going to use combinations. So there are 5 boys. We are going to choose 3 of them to bring show and tell, and means multiply. There are 4 girls. We will choose 1 to bring show and tell. Or there are 5 boys. We will choose 4 of them to bring show and tell. You can type that into your calculator directly as it's written on your paper, and you will find out there are 45 ways that that can happen. Okay, now moving on to an example with a deck of cards. We want to know how many 5 card hands contain at most 2 clubs. And so at most, as a reminder, is a maximum of 2 clubs. So that would mean 2 clubs or 1 club or no clubs. Now, again, you need a 5 card hand. In none of these instances do we have 5 cards in our hand. If we have 2 clubs, we would need 3 that are not clubs. If we have 1 club, we would also need 4 that are not clubs. And if we have no clubs in our hands, that would mean we need 5 cards that are not clubs. Okay? So again, using those ands and ors and the total number of cards in each category, we can set up the way to count this. So if we need 2 clubs, there are 13 clubs in a deck. We are going to pick 2 of them to be dealt to us, and indicates multiplication. There are 39 cards in the deck, all of the diamonds, all of the spades, and all of the hearts that are not clubs. So 39. Choose 3 clubs to be in our hand, or indicates addition. 1 club, there are 13 in the deck, we will choose 1 of the 13, and 39 cards in the deck that are not clubs, we will choose 4. Or since there are no clubs, we don't need to even worry about that one, but we'll go to the 5 that are not clubs. So 39 cards in the deck, we would be dealt 5 of those. Again, if you want to do those separately in your calculator, you can, but you can type it in as one big problem, and you will find there are a mere 2,357,862 different hands that you would end up with at most 2 clubs in your hand. Now, before you look at the next one, please pause the video and set up how to do this problem again like we did in words, and then write out what that would be in terms of combinations before restarting the video and seeing how you did. Okay, welcome back. So as a reminder, at least 1 means a minimum of 1. And since they're taking 3 people to the International Space Station, that could mean 1, 2, or 3 Americans. But make sure you have a total of the proper number of Russians. Sorry, I just realized I have a mistake in here. Let me fix it real quick. It would be 2 Russians if we have 1 American astronaut, not 3. So 1 American and 2 Russians, or 2 Americans with 1 Russian rounding out the 3, or 3 Americans. Again, using those and mean multiply or mean add. Go ahead and fill in how many Americans are available, how many you want. how many Russians are available, how many Russians you would want to go to the space station, and that will give you a grand total of 145 different ways that at least one American could be selected to go to the space station.